Good morning, all of you. On behalf of Department of Computer Science and Engineering, Chalapati Institute of Engineering and Technology, I welcome all of you for the webinar on computer vision for self-driving cars. So let me introduce today resource person, Dr. B. Gayatri Garu. Dr. B. Gayatri is an associate professor of computer science from Bishop Heber College since 2008. Love to explore and research and process and scientific mechanisms underlying the world we live in. Passionate for greener environment, which paved the way to proceed with research in green cloud computing. Explored many online courses and 46 completed from Coursera, Udemy, BIET Simple Learn. Have presented 149 papers, published 25 journals and 1 book, received 37 awards such as International Women Innovator of the Year, International Young Scientist of the Year, Guide of the Year, Best Researcher, Women Researcher, Young Achiever for my research, teaching poetry, social work, etc. Attended 162 seminars, conferences, workshops, training programs, 1 book edited as chief editor, published 1 book and 7 book chapters, 48 invite talks, guests for various occasions, serving as reviewer in journals, and published 9 patents, 1 consultancy holding 6 professional membership, organized 30 various seminars, workshops, training programs, and conferences. Thank you so much, madam. Thank you for accepting our request and coming as a resource person for this webinar. Over to you, madam.
Thank you, sir. Thank you so much for your warm welcome. I wish to thank God Almighty for giving this wonderful day for us to meet you all, the learned scholars and learned professors here. And when I wish to express my heartfelt thanks to the administration for giving me the wonderful opportunity. And the next 60 minutes, I hope we'll be giving justice for that. And kindly acknowledge whether my screen is visible so that I'll be able to move on.
No, madam, your screen is not visible.
Yes, sir. Yes.
Yes, madam. Now it is visible.
Yes, Professor. Thank you so much. And today we are here to see about the topic computation for self-driving cars. So as we know, in a technological era where we live in right now, everything is becoming technological based and everything is become automized. So we people think of those things, and here comes the self-driving cars for that. And already some cars are in existence also right now. And we are going to see about that how the computer vision is going to be helpful for this self-driving cars. So self-driving cars, as we know, it is going to be the car which is going to be capable of safely moving. That is the main important thing. Every people think of it. The safely moving is more important because we are going to travel in it. So the safe is more important. Through the roads with little or no human interference. So the levels are there, which is defined by the SAE. We have the levels from 0 to 5. So level 0, it talks about the no driving automation. And level 0, it is about driver assistance. And level 2, it is a partial driving automation. Level 3, the conditional driving automation. Level 4, the high driving. And level 5, the full driving automation. These are all the levels of the self-driving cars which are in existence right now. So what are the steps they involve? The self-driving cars, they are going to involve certain steps. And that is the first one comes in perception. Perception means we need to understand the environment through cameras and the sensors where the car is going to move. We have to understand the environment completely. The whole environment should be under the control. And it could be under the control only through the cameras and the sensors. They will be able to tell us what is around us and what is in the surroundings. So we will be able to perceive that perceptions comes through the sensors and the cameras. And step 2, it is going to be of localization. We have to locate the car or ourselves in the environment. So it is going to locate itself in the environment. When the first step is getting completed, the perception is completed, only we will be able to locate ourselves. And third comes the path planning or the motion planning. So after we are perceiving about the environment, we are able to localize ourselves, and then we will be able to plan. So the decisions about how to move through the world and create the trajectory. So how to move through. So getting all the information about the environment, and after locating ourselves, we will be able to decide how to move on. And final step is going to be the control, that is execute the trajectory plan by activating the vehicle, because we have planned. The trajectory plan is now in our hand. So after that, we are going to activate our vehicle according to the plan. So these are all the steps where the self-driving cars, they stick on. We need to perceive, localize ourselves, path the plan, and then we have to control. So this perception about locating the environment. So how it is being done, how the self-driving cars they perceive. So the perception comes out of two things. We call it as the computer vision plus sensor fusion. The perception comes only out of this. And here comes the computer vision. The cameras, the sensors like radar, lidar, and the ultrasonic sensors we will be using in the cars. The fact is that the Tesla's autopilot system currently uses 8 cameras, 12 ultrasonic sensors, and forward radar to read lane lines and detect the nearby cars. This is a fact right now. The Tesla is using this kind of mechanism. The computer vision, actually what it is going to be the subfield of the artificial intelligence that trains the computers to understand the visual world, enabling them to see the world in finally. So everything is the base from the artificial intelligence alone. So through the artificial intelligence, we are training the computers to understand the visual world. And to understand the visual world, we need to perceive everything over there. And after that, we'll be able to enable them to see the world and then decide. So for example, detect whether an image contains cat, or it is going to identify the signals, and is going to diagnose the cancers from the medical images. Like that, we have many examples. So this particular perseverance we will be seeing for identifying the signal and whether any obstacles. For example, we given us here as a cat. So whatever it may be, it is going to check it out whether there is any obstacle in its motion planning or path planning. So this is the way the computer vision is going to come into this self-driving cars. So without the vision, we will not be able to proceed. So the computer vision, the major perception problems to solve using computer vision, the perception is going to be the major problem we have to take into account. So for that, 3 things must be taken into the things. What are they? The line detection, obstacle and road signs, or the lights detection, and steering angle computation. So how to move on, we have to decide the steering angle, and that will be computed according to the computer vision data. So the lane line where we are going to move, that lane line must be detected properly, and we have to see about the obstacles in the path where we have planned to move on, and we have to concentrate on the road signs even. What are all the road signs given, whether the zebra crossing or many road signs we have, U-turn and many things, and we have to take into account of all the road signs in the path where we are going to move on. And the lights must be detected, the road signals, the lights, they also must be detected. So all these things must be taken into account, and based on that, we are going to move. So the lane line detection, the line, the motion planning, the path planning, we said that must be detected properly, that must be identified properly. And these are all the steps for that. We'll be using the carrying edge detection and the whole transform for this. And we can see the picture first of all, then coming to these steps will be more easy for us to get into this point. So this is the lane line detection. The 6 steps is given as a picture here. So the motion planning the road where we are going to move. So the first, that the path where we are going to move on is going to be pre-processed. And this is going to be the pre-processed image. The road where we are going to move, that is pre-processed, and the pre-processed image we are able to receive. And we are going to use the scanning edge detection method. Edges are detected properly, only the edges. So after applying the scanning edge detection to this particular image, we are able to receive the third image. The edges are detected properly. And now we need only the lane line, the moving line, the moving space for the car to move or whatever it may be. So here comes the masking step. The other edges which has been detected using scanning edge detection, we're going to remove all those things. Only the lane where we are going to move on is going to be there. So masking is done. So we are able to get the left and right end alone. And now we apply the who transform in that, and we are going to extrapolate it. We can see the image of extrapolation after applying extrapolation, and now the overlay. So the same motion path, the lane line, what we have detected, and now after applying the overlay, we are able to identify it very clearly where we are going to move on. Then once this lane line is detected alone, we will be able to move on in that clearly. So these are all the steps. First, we are going to pre-process the image using the grayscale and Gaussian blur. Using these two techniques, we are going to pre-process the image. So on number 2, we are going to apply the canny edge detection to the image. So the image what we have received, we are applying the canny edge detection. And number 3, we are applying the masking region to the image. To the particular image, we are applying the masking region, thereby which we will be able to get the edges properly, the left and right edge. Other than the natural things, what are all existence over there, that is not going to disturb us with the motion path where we are going to move on. So we are applying the masking region. And after that, we are applying the whole transform to the particular image. And step 5, we are going to extrapolate the lines found in the whole transform to constitute the left and right lane lines where we are going to move on. And finally, the 6th one, we add the extrapolated lines to the input image. The extrapolated lines is added to the input image, thereby which we will be getting a clear lane line is going to be detected out of all these steps. Some terminologies in computer vision. Certain terminologies we'll be using, and they are image classification and image localization and object detection. So we need to classify the image first of all. Then we will be able to identify the traffic signals, the obstacles, the lane lines, whatever it may be. So the computer vision terminologies, it sticks on with these 3 important terminologies. First, we need to classify the images. And those images will be localized then. The particular image, what we are looking for or what we are searching for, it will be localized from the classified images. So image localization is another important terminology. And object detection, that particular localized image, whether we need to compare it with any object, what we are detecting it for, that will be done as object detection. So these are all the important terminologies in computation where we'll be using when images comes into existence. So computer vision, as we know, it is going to give us a visionary information about the place or about the area, whatever it may be. So it is going to give us a complete information. So the obstacles, the road signs, the lights detection. So we are going to follow some steps for that to find out the obstacles, the road signs, and what are the lights which has been detected, the street lights, the traffic lights. We have taken into all these accounts. So the pre-processing like grayscale conversion and normalization is applied. Feature extraction like history of oriented gradients, HOG features is applied. And we're going to try a linear SVM classifier for it. We use the sliding window technique to look for objects in the images. And we estimate the bounding box. So bounding box is that which is going to give us a clear picture of the obstacle or what it may be. As we have seen the lane line detection, it has been giving us the right and left lane lines clearly. The same way here we are able to get the obstacles, it will be estimated in the bounding box. So inside the bounding box, we are not supposed to move on. So outside the bounding box, we will be able to move on safely. That is no problem. We can move on. So the bounding box is that we should not touch on it. So here on the image, you'll be able to see the oncoming car towards us and a bicycler. A pedestrian is moving on. So all these are going to be the obstacles. We cannot move on when these obstacles are there. So we need to apply all these things, grayscale conversion, normalization, and the HOG feature. SVM classifier must be done, and sliding in window must be used to look for the object images, and finally estimating the bounding box. So these are all going to be the obstacles and road signs and lights detection. We need to, we will be able to see in different colors. They are being classified. The traffic lights is being classified, and the person, all the person who are all moving on, they have been classified. And bus, it is classified. Truck, whether any truck is moving on, 3 trucks are moving on, and cars, how many cars moving on, and even the person handbag is being located. Yes, so all these things are detected and they are located properly where they are and how we need to move on amidst them. So what is the safe move on picture we have? So getting all these obstacles and then we'll be able to find out which is going to be the safest way to move on. So we have the word deep learning. The deep learning is going to be the subfield of the machine learning inspired by the function of human brain. We know this human brain and how it is. Many bio people will be knowing about that, and even us, some of us will be knowing that a simple thin nucleus we'll be having, and the cell body we have, and the dendrites thing, and branches of axon will be there, the axon and branches of the axon. So what is happening here actually is that the impulses are carried towards the cell body and the impulses are carried away from the cell body. The impulses is going to be an important thing over here. So the impulses which is carried towards the cell body and the impulses which is going to be carried away from the cell body, that is more important here. So based on the impulse alone, the reaction will be taking place. So what are all the steps to be taken and other steps? So that we have the artificial neuron. So artificial neuron, we have X1, X2, X3 in that rational neuron, and we have the what are all the signals which are coming inside, and that is going to react, and we have the activation function along with the what are all the signals and what are all the steps which is taken on. We have the activation function. So the artificial neural network, we will be able to see here we have hidden layers, 2 hidden layers. the input and output. So the two hidden layers inside, they also work on along with that to get the output. So directly the input is getting in and it works in the hidden layer. The final output alone we will be able to see in the output layer. So the convolutional neural network, CNN, will be seen everywhere. And this is going to be the special neural network which are designed specifically for the image related task. And that we also use in the self-driving cars, image related tasks, because everything we have identified as the images, bus, truck, car, and even the handbag of the person, everything. So it is going to be specifically for the image related task, we use a convolutional neural network. Since the input here is going to be an image, certain properties are exploited to make it more efficient actually. We need to exploit certain properties. The weight is sharing by means of the kernels, the weight are being shared, and the different layers in the CNN or the convolution layer, it is going to compute the output of the neurons that are connected to local regions in the input, which are going to be connected to them alone. And we have the ReLU layer, which applies an element-wise activation function. So when element-wise activation function is applied, we find the maximum value. And next is the pool layer. It performs a downsampling operation, which is of more importance. And then the fully connected layer, they compute the class score. Finally, it will be completed with the computation of the class score. The hidden layers we have seen, which is going to act as some form of feature extractors. Those hidden layers, they take off the feature extractor work. The deeper layer capture high-level features like the parts, the objects, whereas the initial layers capture the low-level features like edges. The initial layers, they take care of the edges, and the deeper layers, they capture the high-level features like the parts, the objects. That will be taken care. So the two layers, they work on in their own way. Initial with the edges and high level with more features and more data and more thing which is going to be computed for the next analysis. So this is the convolution neural network as we have seen the various layer, the CONV layer, what it is doing, the ReLU layer and the pool layer, what it is doing. And we will be able to identify many things, that how many cars, trucks, airplanes, ship, cars are coming on. So based on this, what are all the obstacles available on the road, we'll be able to predict. And we all know about the YOLO mechanism. You look only once. So an image is going to split up into small grids, and the entire image is going to run through a convolution neural network, and we get a class probability map, which tells us the probability of each grid cell belonging to a particular class. We will be able to identify it. So each grid cell, they belong to a particular class, and we will be able to give a differentiation between all of this. So when we are able to get the probability map on each grid cell, we will be able to classify it with each particular class for all the things. That is the advantage of this. So why we use deep learning here? In the computer vision for self-driving cars we talk about, and we also take into account of the deep learning. So no need of the anchor features, neural networks can learn the features themselves. They will be able to learn by themselves, as is going to be a branch of the AI. So it can make use of the abundant data available, whereas traditional machine learning algorithms seems to saturate. They seems to saturate but this, they will be able to make use of the abundant data available. And it is going to have the high quality results. In finally, we are going to have the high quality results, and it can make use of the GPUs for the faster training. They will be able to make use of that, and they will be able to train themselves in a faster manner. Points of deep learning is that black box is going to be less explainable here, and it needs a high-end computing resources, which makes it more expensive actually, because we need the high-end computing resources. Then only we'll be able to apply it and find all the lane line detection and the motion path planning must be done, and the obstacles, whatever it may be, the traffic signals, the traffic lights, everything must be taken into account. So we need a high-end computing resources, which actually when we go for the high-end, it becomes more expensive, and it requires a large amount of data for a decent performance. Yes, we need large amount of data, because as we have seen in that picture, the cars, trucks, the pedestrians, the traffic lights, everything is identified. Even the bag of the pedestrian is being identified. We are able to see in that particular image. So we need more and more data. And minute data, everything is accountable for us. So we need a large amount of data to perform better, for decent performance. We need all these data. The challenges in the self-driving cars, we'll be able to see in this picture very clearly. We are able to predict everything in the lane line detection. So after getting the lane line detection, after finding the motion path where we are going to, it is going to be clear. So even then, certain things are happening in between, which are not predictable. So which is more possibility, more possibility is there. So not able to function properly in the chaotic inner city environments. So in highways and other things, it is okay, fine, we'll be able to move better, and all the detection and other stuff will be able to perform good. It is fine. But when we talk about the inner city environments, where there is a possibility of chaotic things, because it happens in inner city environments. Hope you all will agree to me. So the security issues like hacking or hijacking the car's computer also is possible. Yes, security issues is there. And changes to the road infrastructure for optimal functioning. They usually change the road infrastructure then for many reasons. For many reasons, it happens in the university environments. And handling unseen and peculiar situations also is, there is a possibility. Unseen situation, it is going to be a peculiar situation. We are not expected of those things. And the moral, financial, and criminal responsibility for crashes and the breaches of law is there. So these are being the challenges, as we all will agree. These are all the more possibilities for the self-driving cars to not to use here, it because these are all the problems. So we need to see to that. So Waymo one, hope we all would have explored that. It is a self-driving car, Waymo one. This is a picture of it. And the fact about this is the self-driving car by Waymo LLC, a subsidiary of Alphabet Incorporation. The self-driving taxi service is provided in Phoenix, Arizona. The service was opened to public recently in October 2020. This is going to be the only self-driving commercial service that operates without safety backup drivers in the vehicle. We don't have any safety backup drivers in this vehicle. It is in existence. And now we can see about another thing called Google self-driving car. About that, we can go through once. So this is the Google self-driving car. And about it, we are going to see about the introduction of it, technology, what it is using, and what is it actually, and how it's going to work, equipment which has been used in that, and advantages, limitations, and finally the reference of all those things we'll be giving here. So the introduction is that the Google self-driving car is actually a project by Google, which involves the developing technology for mainly the electric cars. It is actually the project by the Google. They involve the technology for mainly the electric cars they are taking into account. The software installed in the Google's car is called the Google Chaffer. It is being called as Google Chaffer. The project was formally led by Sebastian Thrun, former director of the Stanford Artificial Intelligence Laboratory and the co-inventor of Google CPU also. And Google, they have planned these cars available to the public in 2020 itself. The technology, what they have used is that the project team has equipped a number of different types of cars with the self-driving equipment. including the Toyota, the Audi TT, and Lexus RX 450H. Google has also developed their own custom vehicle, which is assembled by Roche Enterprises and uses equipment from Bosch LG. The Google robotic cars have about $1,50,000 equipment, including of $70,000 LED AR system that is being included in them. So the laser, what we use here, it allows the vehicle to generate a detailed 3D map of its environment. Here we can see it is going to give us a detailed map. So after getting the detailed map alone, we will be able to decide how to move, and the line what we are going to use, everything is going to be clear only. We'll be able to move, and this detailed 3D map is going to help for it. The card that takes these generated maps and combines them with high-end resolutions maps of the world. We are going to be combined with this. So as of June 2014, the system works with a very high definition inch precision map of the area where the vehicle is expected to use. So what is it actually? It is the first truly driverless electric car prototype built by Google to test the next stage of its 5-year-old self-driving car project. It looks like a cross between a smart car and a Nissan Micra, with 2 seats and room enough for a small amount of luggage we'll be able to keep it on. So it is the first real physical incarnation of Google's vision of what a self-driving car of the near future could be. So we are able to understand how the near future could be. With the help of this car, we'll be able to understand it better. So how it is going to work? It is actually powered by an electric motor with around 100-mile range. The car is going to use a combination of sensors and software to locate itself in the real world, combined with highly accurate, detailed digital maps will be there. And it is going to be locate itself in the real world only out of this high accurate digital map. A GPS is actually used here, just like the satellite navigation system in most cars. To get a rough location of the car, we'll be using at which point the radar, lasers, and cameras take over to the monitor to world around the car of 360 degrees. All these things help in that. We have lasers, we have radars, cameras, where we'll be able to understand the 360 degree of the car, where it is going to move on. 360 degrees will be taken into account and we'll be able to decide. The software can recognize the objects, it can recognize the people, the cars, the road marking, it will be able to recognize signs, even traffic lights, and it will be able to obey the rules of the road and allowing for multiple unpredictable hazards. It will be able to adapt, including the cyclist, and it will be able to even we'll be able to safely navigate around them. So here it is going to be better because it will be able to even detect the roadworks and it will be able to navigate accordingly, because roadworks, it happens, it is unpredictable one actually. So we'll be able to get all these data also here. The equipment, whatever the equipment they are using is the LiDAR system, the video cameras, radar sensors, ultrasonic sensors, central computers. These are all the equipments which are used in the Google car. This is the LiDAR. We all know it is a LiDAR sensor designed for the obstacle detection and navigation of the autonomous ground vehicles. It is used for this purpose, for obstacle detection. And to navigate the autonomous ground vehicles, we are using this LiDAR. The video cameras, different types of cameras installed at various locations. And we will be able to get the data from all the necessary locations, and we will be able to plan the next move. By artificial intelligence, the deep learning, with the help of the computer vision, we will be able to, the vision will be able to move on. And we have the radar sensors here in this point of the car. The radars are installed at the front and back side of the car. It has been installed over the front and also at the back side of the car. And we have the ultrasonic sensors here. And it is used to measure the position of the object very close to the vehicles, such as other vehicles while parking. So we are going to take into account the measure the position of the object. And here comes the central computer. The information from all the sensors is going to be is analyzed by central computer. It is going to manipulate the steering, the accelerators, the brakes. It manipulates everything because information from the sensors, and after those information only, it is going to manipulate all these things, steering, accelerators, and brakes. It is going to take into account. So we can see this first of all. We have the laser sensor, which is going to scan the 360 degrees around the vehicle for the objects. And we have a processor, which is going to read the data and regulates vehicle behavior. Reading the data, and accordingly, the vehicle behavior will be regulated from the processor data. And we have a wheel hub sensor, which detects the number of rotations to help determine the car's location. From the sensor, from the number of rotation, we will be able to identify the car's location right now. And we have an orientation sensor which tracks the car's motion and the balance. The motion of the car, the balance of the car is going to be more important, and the orientation sensor is going to track it. The radar, it measures the speed of the vehicles ahead. Ahead of this vehicle, what is the speed of that particular vehicle? We will be able to measure it with the help of the radar. So this is the parts we are using. So the sensors, the hardware components that have been custom built for the self-driving, and the new technologies to protect pedestrians, including flexible windscreen and front made of a foam-like material. An electric battery we have. The speed is capped at 25 miles per hour. And we have primary and backup systems for steering and braking systems. And software is designed to drive from point A to point B without requiring any human intervention. We will be able to move on. And inside, we can see seats for 2 passengers and a space for their belongings also. A button to start or pull over will be available. We will be able to start or stop. And an emergency stop button also is available. And we have a screen which is going to show us the route where we are going to move on. A screen will be there inside with all the necessary information over there. And we will be able to see the information and we will be able to identify it. So the advantages, why we are using it, it manages the traffic flow, relieving the vehicles and avoids accidents, and increases the roadway capacity, it determines the current location. These are all going to be the advantages of using this. The roadway capacity will be improved, current location will be determined better. So coming to the limitations, the vehicles can be switched off on the road. In rare cases, it might happen. There is a possibility. Yes, vehicles can be switched off. And less security when using the internet. That is also again a problem here. When we are using the internet, security becomes a very sensitive topic here. So the hackers can be that they can change the rules. In rare cases, it might happen. There is a possibility. And in case of failure of sensors, vehicle can create a chance of accident. In some cases, if sensors fails to do their work, because based on the sensor information alone, we will be able to proceed on. So in case of failure of the sensors, it is going to create a chance of accidents. There is a chance. And in rainfall, the car cannot be recognized the traffic signals. That is again a problem here. When it is in rainfall and it is a rainy climate, the traffic signals cannot be recognized properly. So we need to take into account of all these limitations also. So these are all the rare cases actually. The switching off on the road, the hackers, these are all the rare cases, but even it is a limitation. And these are all my references where I have moved on. And you can also go through these references. Any clarifications we can discuss now. Over to the organizers.
Thank you, madam. So participants, if you have any doubts, you can please raise your hand or you can type your doubts in the chat box. And also feedback link is posted in the chat box. Please fill it. So if you have any doubts, please raise your hand so that I can unmute you and you can ask your doubts.
It is actually a very interesting
Karthik, you can ask
topic
your
nowadays.
Good morning, ma'am. Thank
Good
you for
morning,
this
sir.
webinar. It was very useful.
Thank you so much.
Ma'am, but what is steering angle computation, ma'am?
Come again?
What is steering angle computation?
Speeding computation. I could not get you. Speeding.
Steering angle computation.
Steering computation. Steering computation is that. So as the lane line, the right hand lane line we have detected, and the motion path we have detected. So everything is detected. So now we have planned to move on. So as we move on, steering computation comes into playing a vital role, because where to move on, whether there is any bend over there and we have to turn or whatever it may be, steering computation works over there when we want to take a left or right, or when we have to move on. So we need the steering computation where it shows us where to steer and how to move on, where to bend on. So there comes the steering computation. On working on that technique alone, we will be able to move further.
Okay, ma'am. Thank you, ma'am.
Thank you so much.
Shivarangani,
And this is
you can
going
ask.
to be a very interesting topic nowadays, because the technological world moving on this. So many researchers also is moving on this particular area.
Hello.
Yes, madam.
Actually, any software is available to check over these technology, ma'am?
Right now we have softwares, ma'am, but that softwares, it is working on the basic mechanism. It is like a demo only, and I have given the references, and you can search over the references where you'll be able to get all these data what I have shared, and many more also you'll be able to get it on, because we have a simulation tool alone right now. So with that, we'll be able
Yes,
to
ma'am.
check out how it is going on, and we can. Yes, ma'am.
Okay.
We have a
In
simulation tools. It is in the reference available.
okay, ma'am. In reference, you
Ma'am.
have given some. Ma'am, in reference topic you have given, no, ma'am. There, if I search now, can I get that simulation softwares, ma'am?
Yes, ma'am. Simulation softwares are also available over there, and you can research it. You can do it very well. You can do it.
Oh, yes, ma'am. Okay, ma'am. Actually, I'm doing PhD regarding that, ma'am. That's why some.
Yeah, fine, fine. Sure, ma'am. You'll be able to get some information, I hope.
Okay, ma'am. Sure, ma'am. Thank you.
Thank you so much.
So any more participants, if you have any doubts, you can raise your hand or you can type in the chat box. Feedback and attendance link is posted in the chat box. All of you please fill it. Ma'am, no doubts, ma'am. Thank you so much for your wonderful session.
Thank you, sir. Thank you so much. I wish to thank all the um, uh, people over here who have spared your valuable time with us. And I hope I have given some justice for it. And I wish to thank the administration wholeheartedly for giving me this wonderful opportunity. Thank you so much, one and all.
Thank you, madam. Those who have filled the feedback form can now leave. Thank you. All of you, please fill the feedback form, and those who have filled the feedback form can leave now. Thank you. You will receive the certificates within 1 day.